Hello, everybody, and welcome back to the Routing Loop. And today we're going to be talking about the art of managing networking trade-offs. We're continuing our series that we've been doing with the Chalk Talks from reInvent 2025. All the highly rated sessions are being redone, if you will, on the Routing Loop to give all of you the opportunity to ask the same questions that those who want to reinvent got to ask. And today I'm joined by Yusra and Yashar. Can you guys tell me, I'll start with Yusra. Tell me who you are, what do you do for AWS, how long have you been here? How are you a networking nerd just like me?
Yeah, thank you, Jamie. So hi, everyone watching. I'm Yusra. I'm an Associate Solutions Architect at AWS. I have been here, I'm in the UK. I'm on the UK public sector team. I've been here for 5 years. I joined as an apprentice in 2021. And yeah, that's a little bit about me.
Awesome. And what's your what drags you to networking?
I was just curious during my apprenticeship about networking, and so I took the AWS certification for networking and joined the TFC, and it was, a really good experience and opportunity to learn lots and talk to different customers.
Cool. Yeah. And for those of you who are watching, TFC means Technical Field Community. It's a bunch of folks that are all aligned on a specific type of technology like networking and such. So that's where all of your networking help comes from. Hey, Erie. Hey, Ken. Hey, Dominic. Glad to see all of you guys here. Now I'm going to shift over to Yashar. Yashar, tell us about who you are, how long have you been at AWS, and why you're a networking nerd like us.
Jamie, thank you. I've been with AWS for the past 7.5 years. I'm a senior solutions architect, just like you, based in London. First 5 years, I was with UK enterprise customers. And as of 2.5 years ago, I joined our global financial services. So I work with some of our biggest financial customers. Background in networking and security. So when I joined AWS, I also thought that it would be really good to, join that community of experts in networking. So that's why I joined the networking technical field communities.
Nice. Yeah. So that's awesome to hear. It's kind of rare, right, to find folks that are, one, interested in networking, and two, good at it. So I'm glad to have you guys on the show, and I'm glad to bring you to our audience. So Yusra, can you tell us a little bit about what you're talking about today? I'll bring up your slides.
Yeah, so today we're going to bring to you some main topic areas which we hear frequent questions from customers. So that's traffic inspection, VPC connectivity, hybrid segmentation, and microservice communication options. And there's various different network designs you can have for each of those. So we're going to discuss the different options and the various trade-offs that are involved in those different designs. Yeah, so.
Cool. Yeah, why don't you take it away?
Okay, great. So I think I kind of just answered what we mean by trade-offs. So I'll go to the next slide. So these, you can think of these as the main foundations or cornerstones to your AWS architecture and network design. And depending on your business needs and your technical priorities, you would need to prioritize each of these differently, and often they're also opposing forces as well. That's why it's so important to balance these most effectively for your specific use case. And we'll be referring to these throughout the session, so you'll hear us refer back to each of these pillars when comparing the different options. So I'll start by giving you some, to put this into perspective, I'll give you some examples of different trade-offs within those design pillars. So firstly, with performance versus cost, there's an example of, imagine you have a site-to-site VPN, and then you want to improve the performance on there. So you upgrade that to accelerated site-to-site VPN. That's great because the performance is now improved because you're bringing traffic onto the AWS backbone sooner. But then you're also now incurring an additional cost for the global accelerator endpoint hours. So that's something to bear in mind. And then scalability versus complexity. We often see these two design pillars competing against each other. In the networking world, you might have your VPC peering set up for VPC connectivity. And that's great because intra-AZ data transfer is free, so you might be benefiting from that. But then as your network scales and you need to manage that full mesh network connectivity, can be really complex and operationally difficult to manage. So with that complexity, you might want to pivot to transit gateway or cloud WAN. High availability versus cost is another pair of design pillars that might go against each other. So for example, with your direct connect connections, you might have multiple connections, say 4 links, and you'd have that high availability and resiliency, and that's great because you can have active standby connections, but then you're going to be charged for those even whilst they're on standby, and there's additional costs. Scalability versus operational efficiency. The example with that one is transit. So it's great to use transit gateways to interconnect all your networks and your VPCs, but then once you have a growing microservices that need to communicate between each other, you can pivot to VPC lattice for operational and security efficiencies. Yeah, and then security is always a top priority, so you should never trade that off, and keep that in mind.
Security is job zero.
We do have one question here. How does the choice of routing algorithms influence resource consumption versus network performance?
How does the choice of routing algorithms?
Maybe I can take that one. Choice of routing algorithm, usually talk about maybe in the on-prem environment, definitely we talk about different routing algorithms. If I read the question correctly, such as, for example, ERGRP, OSPF, BGP. What we discuss in the context of routing on or dynamic routing on AWS is always BGP, and it always comes in the context of direct connect. So it's not a choice. We have to configure BGP peering when we configure direct connect. So I'm not sure if I answered that to
yeah,
point.
Lewis, if you want to give us a little bit more clarity, but I'll also take a little bit of crack at it as well, is that when you're also looking at like how you're routing through a service, just keep in mind that, like, say if you're looking at a VPC or a virtual private cloud, right, we've got routing possibilities with a default routing table as well as routing possibilities with our subnets. When you're looking at transit gateway, you've got routing that you can set up with your associations and propagations. When you got cloud WAN, you've got your policies. Now, typically these routing algorithms, these things that you set up, each route or each hop has a consumption or a cost. So when you go through something, a managed service, or you go through an endpoint, that'll have a cost, right? And then the other vector I think that Yusra was mentioning too is management and complexity. So if you're doing something like a bunch of transit gateways, right, as Yusra was mentioning, you have to set up all the static routes if you have like 5 or 6 transit gateways all kind of meshed together, whether they're in the same region or multiple regions. But one of the things that you can do is you can move to cloud WAN, which the trade-off would be now you're looking at a infrastructure as code, but now you can manage it more in a single place, right? So I think this is what you're getting at. But please, Luis, if there's any clarification that you can give us, go ahead. But in the meantime, why don't you continue on, Yusra?
Okay, thank you. So yeah, I'll jump into the first of the topics that I mentioned, so traffic inspection. And this is a typical architecture that you'd have for traffic inspection, so east, west, and north, south, so VPC to VPC, and then on-prem to AWS and vice versa. And it's using transit gateway and segmentation to make sure that traffic between each of the workloads is inspected before reaching the destination. So here we have a centralized inspection architecture for east-west traffic and also internet ingress. And the Amazon Network Firewall endpoint has been deployed centrally into the inspection VPC. And yeah, so traffic between the workloads would flow via the transit gateway, and then internet ingress traffic would come through the main internet gateway here, be inspected before reaching the workload VPCs. Okay. This model can also be simplified with the new native network firewall attachment for Transit Gateway. And that's really great because it reduces some of the operational overhead you have to do by deploying the network firewall endpoint and the Transit Gateway ENI into the managed VPC for you, and also helping you out with configuring some of the routes. But then if you have internet egress traffic, you'll need a NAT gateway, and that doesn't come with a managed VPC, so you'll need to deploy another VPC for that and put a NAT gateway inside. And then you have an additional attachment to configure to Transit Gateway, which you'll be charged for. So there's a very slight trade-off there between cost and operational efficiency. Yep.
We do have a question from Tech. Hey, Tech, welcome back. What are the pros and cons of using the same AWS network firewall for ingress and egress traffic inspection, and is it doable?
Pros and cons of using the same network firewall. So do you just mean what's the pros of using it in a centralized model, essentially?
Yeah, so that it's not only inspecting traffic going out, but it's also inspecting traffic coming in the exact same firewall. So centralized.
I guess, feel free to add, but I guess there's one firewall that you could manage, so it helps with operations, just manage one firewall centrally, the unified policies on there, just manage it in one place. That's potentially one of the benefits, versus with a distributed approach, you have more endpoints distributed to each of the workload VPCs. There's way more endpoints you have to provision, and then there's hourly charges for those. And also you need to manage the policies on those, on the firewalls if you distribute it too. So yeah.
Go ahead, yes.
Sorry, Jamie, I was going to say that also depends on the compliance and governance model in your organization, because I've seen, especially with financial services and other organizations that are very security conscious and security focused, that they want to segregate their egress versus egress path. So if that is a requirement from InfoSec in those organizations, well, you have to do that. You have to have a separate set of firewalls or firewall function for ingress as opposed to egress. But if you do not have such requirement, apart from managing the rules, I don't think there is any problem with having both ingress and egress going through the same firewall. Of course, in this case, we are talking about egress because we're just showing the NAT gateway. If you wanted to talk about ingress, we should be able to expose those services by, for example, application load balancer somehow. So we're not showing it in that diagram, but definitely it's possible. And with multi-VPC endpoint for AWS Network Firewall, there is a pattern that we can also deploy different endpoints. One endpoint in one AZ looks after the egress traffic, another endpoint in the same AZ looks after the ingress. So we can definitely do those patterns with AWS Network Firewall.
Yeah, just some of the takeaways too is when you're looking at the consolidated versus distributed model, as Yusra was also mentioning, you have to take into account blast radius, right? If you're doing everything within one central model, that central model, the error that's going to happen typically is human error. So you have to make sure you mitigate that, right? You want to make sure there's a programmatic way. One of the things I always recommend folks do is to do things via like the API or CloudFormation or Terraform, and which you can certainly do with a network firewall, and then to put that into like a Git repo, make sure you have your pull request, have an easy way to get back if you're going to be centralizing. And distributed models, even though distributed models could be a bit more complex, again, as Yusra was mentioning, you have multiple policies you have to manage, you have the multiple endpoints, and each endpoint has its own security group and routing and all that. But the benefit there is if you put an endpoint as close as possible to the workload, it's quicker, right? You don't have that hop latency. And I do understand that, sometimes some folks might be saying, well, that's tens of milliseconds. Depending on the customer, as Yashar was saying, tens of milliseconds could be a lot. I've heard from FinServ companies that a millisecond could be $1 million. So, it really depends, again, on the business use case. So anyway.
Okay, great. So an alternative to using network firewall, we have the same centralized design, but instead we have we're using third-party firewalls behind gateway load balancer. So there's a few differences to consider between choosing third-party firewalls and Amazon Network Firewall. So firstly, with third-party ones, you would need to manage the underlying infrastructure that the security appliance would be running on, like EC2. So select the instance size and the type. And then for scaling as well, you'll need to manage the auto-scaling group configuration, whereas with the Amazon Network Firewall, it's a fully managed service. And also, one other thing to consider between third-party firewalls and Amazon Network Firewall is the features and the capabilities of inspection that it has and what you need for your specific inspection use case. So that's important to take into account.
We do another question from Luis, and he's asking, how can traffic be interpreted to decide whether a route should be changed or maintained? So I'm going to take a stab at that one if you guys are okay with that. We've got a couple of different ways to look at your traffic, right? VPC flow logs is one of those. CloudWatch metrics is another, depending on the services that you choose. So if you're looking at like just strictly like how's my routing, is my routing efficient, right? You can look at those patterns and make sure those patterns are good. We also have Traffic Analyzer, which is a way that a service that we have that looks at the way a packet would traverse your workload and how each of those pieces would handle that workload. So, and the configurability of it. Even if you have third parties, like Yusra was mentioning, if you went with the gateway load balancer and you had like Palo Altos or Fortinets or whatever in the back and it's part of your path, you can even tell it that you have this as a part of your path. It just can't analyze the configuration of those managed services. So you do have a lot of options to figure out, hey, should you have routes changed or maintained? And is your routing efficient just based on using some of those tools or just analyzing the traffic? And of course, if you're being told that things are a little too latent. But the best thing to do, honestly, if you're getting into those things and you need a little bit more analysis, is to reach out to your TAM and reach out to your SA, and they can really help you out in terms of getting someone from the TFC, such as Yusra and Yashar, myself, to get on the call and talk to you about what you're seeing.
Awesome. Great. Okay, so specifically for internet ingress traffic, we can make use of the already centralized inspection VPC, and we can route the internet ingress traffic through there to be inspected before it gets to the workloads. Or we can give the workload VPCs their own internet gateway and then distribute the data plane by deploying the gateway load balancer endpoints to the individual workload VPCs. And then internet ingress traffic would flow like so via private link to the inspection VPC to be inspected and then go back. And then there's various different options for the design within the workload VPC. So I'm going to zoom into that now and we'll see what we can have. So in the first scenario, which is internet gateway ingress routing, ingress traffic would land first on the gateway load balancer endpoint. So it would be inspected and go to this VPC via private link, and it would come back and then go to the load balancer subnet ENI, and then it would go to the workload subnet, its final destination. You can also create this pattern with Amazon Network Firewall. I think we mentioned earlier, since the new launch of multi-VPC endpoints too. Then the alternative to this is more specific routing. So in this scenario, instead of traffic first landing on the firewall endpoint, it goes to the load balancer endpoint, and then there's more specific routes within the ELB subnet route table so that it then is directed to the gateway load balancer subnet, and then it's inspected at that point before it comes back and goes to the target. So there's a few differences to consider between these two designs. And what are the trade-offs between both of them? Well, we can first consider the cost. So if the firewall endpoint goes first, then it will process all of the incoming traffic. Whereas if you put the load balancer first, then say it's ALB, it can use its listener rules to drop some of the unintended traffic and then save downstream firewall processing charges. And then on the security side of things, if you have a requirement for your firewall to see the original source client IP address, then you'll need to put the firewall first. Otherwise, there is a feature on ALB called X-forwarded for that you can use for that use case. And then something else to just bear in mind is certificate management. So with ingress routing, as the firewall is the first point of ingress, you need a public certificate to be managed on there, whereas with more specific routing, you can have a private certificate on the firewall. Okay, and then, so with that being said, there's the question of whether you actually need a layer 3 or layer 4 firewall, like gateway load balancer or network firewall, or would a web application firewall be enough for your use case? If you're mainly serving layer 7 web, HTTP, and HTTPS requests, then you can use a WAF and it could be sufficient for your use case. It integrates natively with a few of the AWS services like ALB, like seen here, CloudFront and API Gateway. And in this scenario, it's deployed onto CloudFront and the application load balancer. A common question some people have is, would we deploy it onto CloudFront or ALB? And you can actually deploy it onto both as a defense in-depth approach and have broad controls at the edge. So you block attacks closer to the user where they're being made, and then also other access control lists for more granular controls on the ALB at the regional level.
So we have another question from Tech First. Can we inspect traffic between the network load balancer and its target in another VPC?
Can we inspect between the network load balancer and so after it has gone through, can we inspect traffic between?
Yeah, I think this was the pattern Yusra was showing that. Oh, this is network load balancer. Okay.
Yeah, that's
network load balancer and the target. I think, well, network load balancer needs to find the backend target. So I think we have to use more specific routing in network load balancer subnet to point it to the endpoint, the firewall endpoint. And then after that, when the inspection happens, traffic is sent back to the same endpoint and it goes to its registered target. It should be possible. I don't see why it's not possible. And it's very similar to what Yusra was showing in the pattern of traffic is received by the load balancer first. By a more specific routing, we send it to the endpoint, the firewall endpoint. And we have to make sure that for the return traffic, we do that as well. So from the workload, we have to point probably a default route back to the endpoint, and the endpoint send it back to the network load balancer. But I think with application load balancer, we can do that because the session is terminated at the application load balancer, and application load balancer changes the source IP address. We need to consider those network load balancer considerations with regards to preserving source IP address. I might need to take that and have a look at it in more further details.
Yeah, so just keep in mind too, if you're using, there's a couple of nuances for that answer as well. If you're using IP targets, right, with a network load balancer, as Yashar was mentioning, those IP targets need to be routable, right? And they could even be routable to on-prem. So network load balancer, the unique thing with its IP targets, it could be in other VPCs. It could, as long as it's routable, it could get there. Now, if you're routing to get to those endpoints, right? So if you're going across a boundary, any rules that you put for those boundaries, as was mentioned, more specific routing, will come into play. Like more specific routing versus ingress routing. Ingress routing will basically do the bump in the wire and capture the traffic before it goes through the IGW, and more specific routing is before you go to whatever your egress is on that subnet, capture the traffic and send it to something else, right? So yes, You can inspect the traffic of the network load balancer and its targets. If they're in another VPC, obviously you have to be using IP targets for that, and you have to have routability for that. The question is, why? Like, why do you want to inspect that traffic behind the NLB when you can so much easily inspect that traffic in front of the NLB a lot quicker, right? So yeah, there's that. And then Ken had made mention for ANF, AWS Network Firewall, how would you tackle scalability and session handling in case of failures? What do you mean by that, Ken? Unless, of course, Yusra and Yashar, you have an idea.
Yeah, I think scalability with AWS Network Firewall, definitely we look after the scalability in the backend. So for every endpoint, AWS Network Firewall endpoint that you deploy in an AZ or availability zone, we have a cluster of the backend network function responsible for that endpoint in that availability zone. In the back, we look after synchronizing the sessions between those clusters of network firewall. So session handling is happening in the back. We do have a feature with flow capture and flow flush for AWS Network Firewall. So you would be able to specify a traffic specification based on the source destination, and then be able to see whether that has gone through the firewall. So you see the flow, and then selectively or all the sessions or all the flows, you can flush them.
I love that name, by the way, route flush.
Flow flush, yes.
Flow flush, yeah. And then we've got one more question. It says, how can AWS WAF identify and block layer 7 attacks, such as SQL injection and cross-site scripting XXS? This is a common thing that WAFs do, and they usually do it via like pattern matching or URL string matching, things like that, to help you. You could be more specific, saying, hey, I'm expecting this exact string to go to this exact location. If anything is deviant of this string, don't accept the traffic, block it, report it, or whatever it is, right? Which is a common way that people like to do like layer 7 attacks, is they'll come in with like a star or a question mark or something like that. You have anything further to add, Yusra? Yeah.
Maybe I'll just add one more, because with Web Application Firewall, that firewall functionality needs to be able to see the payload, which means that if the traffic is encrypted, it needs to be decrypted. And then, as you mentioned, with pattern matching, looking at the body or what comes in some of the headers, would be able to detect those. So I think AWS WAF is very strategically positioned with integration with ALB and CloudFront, because it's at those locations you can also import your certificates. So when you create a HTTPS listener on ALB, you also need to provide your backend certificate, and that allows for the traffic to be decrypted. WAF would then go through the header, the body, do the pattern matching, and then would drop the traffic based on the pattern that it has found.
Makes sense. All right, well, we move along here, because I know you have 2 other topics to cover. We do have some more questions, but I'll ask them once you move them a little bit further along.
So we have some questions here just to help you decide on the best firewall for your use case. So we've covered top 2. Do you need ingress and egress inspection? So WAF does ingress, but obviously not egress. Do you want the traffic to flow through a central inspection, VPC, or do you want it to be distributed? And then, do you need centralized policy management? Because you can centrally manage your policies in Network Firewall Manager. Okay. So, moving along to cross-region traffic inspection. So you saw how traffic inspection would work in one AWS region with Transit Gateway, and then if we have multiple regions, or if you have multiple workloads across different regions, then you'd need a secondary Transit Gateway for that, because it is a regional service. And then to enable the inter-region routing, you would have to manage static routes in the Transit Gateway route tables. And then another challenge that would provide the challenge of So as you scale and your environment scales to new regions, then there's a lot of routes to manage, and that can become operationally complex. Another thing to bear in mind is you lose end-to-end segmentation because the transit gateway peering attachment can only be associated to one transit gateway route table. So that is something else to consider. And then you can pivot to Cloud WAN. So Cloud WAN brings a lot of operational enhancements for cross-region traffic inspection with service insertion. So in there you can have your security appliances like gateway load balancer or network firewall, and use core network policies and dynamic routing between regions to simplify connectivity. And there's different policy statements that you can have for traffic inspection. So send by a single hop and dual hop. So with single hop, it would inspect it in one region, whereas with dual hop, you would inspect your traffic in the source and destination regions. There's a few trade-offs there to consider. So firstly, with dual hop, as it will be inspecting twice, there's more traffic has to traverse more attachments, and there's a few more hops. So the latency would be a little higher, and the performance isn't as good as single hop. And then also cost is another thing. So if you're inspecting traffic in the firewalls in the source and destination region, there's double data processing on the firewalls. But then it does provide enhanced security if you do dual inspection, and certain customers have a security compliance requirement, which means that they need to inspect it twice in both regions.
Yes, we've got one more question actually that's kind of related to multiple regions, and this is from Lewis again. What challenges arise when deploying WAF across multiple AWS regions or accounts for global traffic?
So one that comes to mind, WAF across multiple regions and accounts, is potentially the cost of your WAF and your WAF web access control lists and the rules that you have. That could be one, potentially.
And you could consolidate that though, depending on what you're doing. Like if you're doing a standard ingress, right? You can, if you're ingressing in multiple regions and you need to look at managing a WAF across all of it, that's usually when I tell people to start looking at CloudFront, right? If it's layer 7 traffic, that is. Because then you can put WAF on your CloudFront. That would manage WAF globally, because CloudFront is a global service. It does, has multiple points of presence or POPs around the globe. And then if you have your macro rules there, and then if you're being routed to individual origins, like saying using API Gateway or ALB, that's where you have your micro rules or your granular rules, right? And those would be different based on the application, as opposed to say something that you would deploy globally on a CloudFront, which would manage access to your site. What do you guys think?
I think we can also take advantage of the Firewall Manager, yes. Because with AWS Firewall Manager, you can have some of the rules that we call pre and post rules. So some of the rules that we want to apply cohesively across other accounts on maybe other load balancers. So we can push those pre-rules to the top. Then every other account, based on the workload requirement, can have their own specific rules in the middle. And then on top of that, we can push the post rules. So you can think of these WAF rules as a layer of different. We can take advantage of something that needs to be applied to all the accounts, regardless of what workloads in those accounts are, but then also give the flexibility of the users in those accounts to apply their own rules in the middle. And we can do that with AWS Firewall Manager. I mean, it says Firewall Manager, but it also applies to security group, WAF policies, and AWS Network Firewall policy.
Awesome.
Okay, and here's some questions in a similar format to the firewall questions that you can ask yourself to see what would be better Transit Gateway or Cloud WAN. So where are you in your AWS journey? How many regions do you currently have workloads in, and what are your plans for expanding in the future? If you do want to migrate from Transit Gateway to Cloud WAN, there are migration patterns for that. And then, do you need flat or segmented network architectures? So how complex is your segmentation? Do you prefer network automation? So Cloud WAN would be great for that. And then, do you need multicast support? So currently that's only supported on Transit Gateway and not Cloud WAN. Yeah, and then you can think of Cloud WAN as a managed service and Transit Gateway as a more do-it-yourself router. Okay, so I'll hand over to Yashar now to dive deeper into Cloud WAN and Transit Gateway in the context of hybrid segmentation. So,
thank you. Thanks, Yusra. And Jamie, maybe I want to go through some of the use cases that I have dealt with before.
Okay.
And those were customers oftentimes asking, how can they extend segmented or segregated network from on-prem all the way to the cloud environment? That could be because they want to have separate environments, such as production, staging, development, or maybe they have different VRFs that they want to extend that all the way from on-prem to AWS. So I think in this section, I would like to go through that topic and explain how we can do that with Cloud WAN as well as Transit Gateway. But before going into how we do that with Cloud WAN, I just wanted to go through the basics of how the Direct Connect integration with Cloud WAN works. So in this case, we've got Cloud WAN and the core network across, you can see that 3 regions. We've got an on-premises environment where, for redundancy, we've got 2 Direct Connect connections. Now, we can integrate this Direct Connect natively with Cloud WAN. Previously, before this feature came out, we had to have a Transit Gateway between, but now we've got this native integration of Direct Connect with Cloud WAN. And how we do that is, on top of this Direct Connect connection, we create a transit VIF and associate this transit VIF with a Direct Connect gateway. And we attach that Direct Connect gateway to the segment that we want to attach it to. So this is a fairly new type of kind of attachment. It's called Direct Connect gateway attachment. When you create that attachment, of course, you specify which Direct Connect gateway you're attaching to a specific segment. And when you use those tag keys and values that you have configured in your Cloud WAN attachment policy, that specific attachment would be attached to a specific segment. When you're doing so, you're also associating that with a subset or all of your core network edges. And that would determine how routing works from AWS to on-prem and from on-prem to AWS. Like anything else, with Direct Connect, which works on BGP, we need to assign autonomous system number. So we have a range of autonomous system number or AS number that when we create our core network, we define that, and those would be allocated to each core network edge. And we need to understand that this range should not overlap with the Direct Connect gateway AS number and your on-prem environment. Now, let's see how routing works here. So as soon as you create that attachment or that Direct Connect gateway attachment, depending on which core network edges you have associated with, those core network edges would advertise their local routes to Direct Connect gateway. So that means they only send the prefixes that they know from that specific region, not from the other regions. And then Direct Connect gateway would just collectively send them back to the on-prem. Similarly, when you advertise your prefixes from on-premise through that transit VIF and BGP peering that you have created, Direct Connect Gateway would tag that with its own AS number and would advertise it to core network edges that it has associated with. Now, we also know that these core network edges, they also form a full BGP peering, a full mesh BGP peering across them. So they also learn from each other about the same prefixes, but of course, because when they send these route prefixes to each other, they also add their own AS number, so that would create a longer AS path, and that makes an on-prem path better path to on-prem through the Direct Connect Gateway in the same region. Now, imagine that, as I mentioned, we want to extend multiple segmented environments from on-prem to AWS. So in this case, imagine that I've got a blue network or a blue TVIF that is associated with Direct Connect Gateway 1, which is attached to, let's say, that blue segment or yellow segment. And then I've got another network, or another VRF, which I will need to create another transit VIF for it, create another BGP peering, and then I would associate that with a separate Direct Connect Gateway, and then attach it to the separate segment. So this way you can have your extension of VRFs or different networks from on-prem all the way to Cloud WAN core network. Now the question is, for how many network or for how many VRFs I can do this? So we know that for a dedicated Direct Connect connection, we can create up to 4 transit VIFs. So this means that I can create 4 transit VIFs associated with 4 different Direct Connect gateways and connect them to 4 different segments. Then the question is, okay, what if I have more than 4 VRFs or 4 segments that I want to extend them? Do I need to order more Direct Connect connections and then create additional VIFs on top of them and then be able to do that? Or is there any other way that I can still do that with maybe 1 or 2 Direct Connect connections? So I think to answer that, I would probably show how we do that with Transit Gateway. So in this case, again, you see multiple in the on-prem side, we see multiple networks or multiple VRFs that, again, we can create up to 4 transit VIFs, 4 different Direct Connect gateways, and those would be associated or attached to different route domains or route tables. But there is another way to do this, which is through Transit Gateway Connect. So in this case, you can see that we only have 1 transit VIF. On top of that transit VIF, we create multiple Transit Gateway Connect attachments, which I can associate with different route tables, and then create Connect Peer, which is obviously the equivalent of GRE tunnels. So I can do that for hundreds or even thousands of different VRFs or networks, because those would be counted as an attachment type. So having said that, we can take the same pattern and then combine it with Cloud WAN. Of course, this has an additional component of Transit Gateway in the middle, but that would allow you to extend a lot of VRFs or segregated or segmented networks from on-prem all the way to your cloud workloads, and of course across different regions as well. So over here you see end-to-end segregation, for example, between the dev environment and prod environment, and that again is a kind of a trade-off. Do you want to do it with more Direct Connect connections and just have the ease of creating more and more transit VIFs, or go through a little bit of configuration overhead and create those Transit Gateway Connect attachments, the GRE tunnels, and do your route table attachment between the Transit Gateway and Cloud WAN? So these are the things that we might need to consider.
We do have one question. I answered already in the chat, but it was from Tech First. With from AWS to on-prem traffic, can we see the full AS path, including the C&E AS number or AS path number on our on-prem router? And I already answered.
Oh, you did. Okay.
Yeah. Go ahead.
I think. Yeah. Okay. I was thinking about the new features that we announced back at reInvent for Cloudland with regards to having visibility to the AS path and also being able to manipulate those.
Yeah, I think from outside of a Cloud RAN perspective, it's generally not seen. The C&E and the AS path are usually not seen based on the way that, with routing and things pass through our direct connect or our meet place edge. So yeah, not there, but I will have to check and see if Cloud1 has something for transparency for AS, but I don't think so.
Sure. I think I can move on to the next topic that we considered for this session, since we also talked about transit gateway and how we can consider different options when it comes to microservices communication. So when we talk about microservices, we're talking about different APIs, different services that could be in different VPCs, even across different accounts if an organization takes a multi-account approach. So what would be the best way to connect these microservices or the consumer and provider services together? Of course, we have a lot of ways of connecting these network together, VPC peering, private link, but I wanted to go through a little bit of comparing transit gateway and VPC lattice in the context of microservices communication. So with transit gateway, of course, as you know, we can connect thousands of VPCs and site-to-site VPNs and direct connect links together. It's a very flexible solution, but one thing you need to always bear in mind that you cannot have overlapping CIDR ranges for networks that are connected to the transit gateway. So you see two VPCs here that are connected to or attached to transit gateway. We cannot have overlapping CIDR ranges. So we have to have a very good IP address planning, even across different accounts, that when we share that transit gateway in our organization and we connect these VPCs together, we should not have overlapping VPC CIDR ranges. From access control, layer 3 access control, of course, we can create multiple route domains or route tables on the transit gateway, and who can access what can be done through that logical routing segregation. Traffic inspection, as we discussed it and Yusra discussed it, we can integrate an inspection VPC in there. But one thing that doesn't come out of the box with transit gateway is authorization. So if you want to deploy role-based access control or attribute-based access control, that needs to be baked into, or that logic needs to be at the application layer. That doesn't come with out of the box with transit gateway. Now, how does that different with doing that same thing with VPC lattice? So the first advantage of VPC lattice is you can connect VPCs with overlapping CIDR ranges. You see in the screen that left-hand VPC and right-hand VPC, they use the exact same CIDR range. And if a consumer from VPC X wants to connect with to a service in VPC C on the right-hand side, no problem, because that service in VPC C is represented through a different IP address, which we call VPC lattice link local IP address. They are in the range of 169.254.171. So they don't have, there's no issue with connecting overlapping VPC CIDRs. From authorization perspective, authorization can be enforced with VPC lattice with auth policies or authorization policies. And those are the policies that can be applied either at the service network level, which is that logical construct that connects these consumers and providers or services together, or at the VPC lattice service level. So with VPC lattice, you create your service network. On the provider side, you create your services in the context of VPC lattice. We call it VPC lattice service, which represents your backend workload, whether in Lambda, EC2, or an ALB, and then you associate these services with the service network. On the consumer side, you also associate the consumer VPC with the service network, and then on top of that, with your auth policies, you can specify or enforce who can access what. In creating those policies, as you can see on the right-hand side of the screen, you can refer to some of the traffic attributes, such as the port number, what is the request method, what is the request header name and value, query string, where this request comes from, which service network this request comes from, which VPC comes from, and you can craft or create a policy, authorization policy, based on all those attributes and apply them either at the service network level, which we recommend you usually apply some coarse-grained policies at your service network level, and then leave fine-grained policies at the service level. So for example, at your service network, you can say, I would allow traffic if it comes from my organization. So you can refer to the org ID, and you can make sure that the traffic belongs to your organization. And then you can move on and create more specific authorization policies at the service level. So this is more, what I'm showing is more in the context of HTTP and HTTPS services. But then we can also expose non-HTTP TCP resources within the VPC, and that's through the resource configuration, which again represents the backend resource. So in this case, could be an RDS. We can refer to that by its IP address, by its domain name, and in the case of RDS, by its ARN, and then associate that resource configuration with the service network. And of course, we need a way for the traffic to hit that VPC resource, which we need to create and deploy a resource gateway. So you see that this is very flexible, and you can include more authorization policies, which in the case of transit gateway, you were not able to do that, and you had to just leave it at the application layer. I'm not sure, Jamie, is there any question?
Yeah, we've got a couple from Lewis,
Okay.
but I want you to. Some of them are scattered about the different topics we already talked about,
Sure.
and we have 7 minutes left, so I want to make sure you have enough time to give your points. If we don't get to your questions, Lewis, I promise we can put together a session and then do this, answer some of those questions in the next session that we do, because I know we have an Ask Me Anything, so we will eventually ask them, but I also see Yusra as rapidly typing as well in the answer. So why don't you continue?
Sure. Yeah, I think I just wanted to, again, provide some pointers in deciding whether you want to use Transit Gateway or VPC Lattice for your microservices or VPC to VPC communication. Again, it depends how many services you have, what type of protocols your application is running on. Is it just HTTP, HTTPS, or you have TCP, or you have UDP? If you have UDP, then definitely use Transit Gateway. Do you need zero trust? Meaning that you allow access not just based on the network location, but also the trustworthiness of the identity that requests that connection or makes that connection, which then refers back to the user or the principal attributes, where this traffic comes from, what type of role they come with, what type of method or things they use, and again, the simplicity of the management. Do you want to again connect all these VPCs to the transit gateway and look after the routing, different route domains, enforcing that who can access what based on layer 3, layer 4 firewall rules, or you want to move it on more to the application layer, understanding based allowing access or authorizing access based on the information in the header and the attribute of the traffic. Just gonna put up some slide that we also have this in our documentation, AWS documentation, comparing various forms of connectivity, VPC peering, transit gateway, private link, cloud WAN, and VPC lattice. I thought this would be a very good and concise table to compare a few of the things that you might want to consider when you're connecting different applications or different services on AWS. I think those are all the topics that we wanted to discuss in this session. Happy to take any questions.
Well, we do have 4 minutes left. I have one question that I'm going to pop up here that is related to what you were just mentioning. For Lattice, TCP resources support only RDS is supported. Right. For Lattice, TCP resources support only RDS is supported, or can it be used with other AWS services such as MSK? I was reading it wrong, sorry.
Yeah. When I said RDS, I was referring to exposing RDS in the resource configuration with its ARN. Yes. That was, but with TCP, you can definitely any backend inside VPC, TCP resource, or even outside VPC. Because when you configure a resource configuration, like I said, resource configuration represents a TCP resource. You can create it by referring to the backend resource IP address or its domain name, and it needs to be publicly routable when you refer to the domain name, or its ARN. If I'm not mistaken, at the moment for ARN, we have the capability with RDS. Mm-hmm. But if you have any other TCP resources that you can represent it with IP address or domain name, that can also be done. MSK is a little bit different.
I think
not going to go through the details of it.
Yeah. You cut in and out. Yeah. So just very quickly, when you're looking at Lattice, as Yasar was mentioning, when you're looking at services, Lattice service-to-service communication, that's typically a layer 7 communication. And when you're looking at TCP resources, we call those resources, right? Which you would put behind like a resource gateway or something like that and associate it to the service network. And that usually works on TCP. And then if you have a UDP requirement, UDP is when you have to look at transit gateway because UDP is not supported over VPC Lattice. So we have 2 minutes left. And we still have so much more that we could have talked about. This is a very broad topic. I'm going to give it to Yusra first. If give us one thought you want everyone to take away from this presentation today.
One thought to take away. Well, I hope you learned something new. That's first thing, and just there's endless networking. Not endless, but there's lots of different networking options you can have in AWS. So I hope you've seen the broad range of those. And yeah, you have a bit more insight into what is best for your specific use case and your organization. So yeah.
Yashar, anything you want to add in 1 minute?
I think, like I said, there are multiple ways of doing the same thing. Always refer to those design principles and design pillars and make the right choice for your use case.
Perfect. And everyone will be back again, same time next week. Different host, different topic, but you can certainly carry the questions from this topic to the next topic. And again, we will try to do a true up meeting of like an Ask Me Anything so you can just preserve your questions. And at the very least, if you need to have them answered right away, please talk to your SA, talk to your TAM, have them get one of us on the phone with you, and we'll be happy to address them directly. Yasar, Yusra, thank you very much for this presentation today. It was amazing, just like it was for your reInvent. And see you next time. We'll have to have you back on the show.
Thanks for having us.